Do you wear the same sweater regardless if it's summer or winter? Regardless if it's sunny or rainy? Well, asphalt has to survive snow, rain, sunshine, and cold for many years, so we need to use the most appropriate fabric, or in this case, materials, to make sure it does. Do you use the same shoes regardless whether you're going to dance a ballet or participate in a motocross? Thankfully, asphalt also doesn't need to do that. We can design asphalt for a specific application. A road taking you to the family home doesn't need to be as strong as a highway leading to a port. But how to make sure that the asphalt survives rain or shine? How to design a pavement that will serve just as long on a highway as it is serving on a pedestrian pathway? We can try to predict the pavement properties using performance-based test methods even before we pave the asphalt. In laboratory, we can test rutting to make sure lorries can use the road, we can test fatigue to make sure it will last long, and we can test low temperature cracking for roads that have to survive colder climates. But why suddenly start testing performance if we have designed pavements for many years without ever doing it? Well, it used to be simple. Take the mineral aggregates, binder, and mix them together. Through long-term established correlations with the field performance, we knew what gradations, binder content, and air void volume will deliver the longest lasting asphalt pavements. The times have changed. We drive ever heavier lorries, so we need to use polymer modified binder. We don't want to harm the environment, so we use warm mix asphalt. We would like to reduce costs, so we recycle old pavements. We hate traffic jams while the road is being repaired, so we design longer lasting pavements. We need to help other industries to recycle, so we use tires and other waste materials in asphalt. Even the binder doesn't stick to the rocks as it used to 10 years ago because of the changed refining technologies. All of this is moving asphalt beyond the narrow margins for which traditional mix design holds true. We need to adapt. Performance-based test methods allow to evaluate the final product, asphalt mixture. If adequate test methods are chosen, we can avoid relying on volumetric parameters as the sole criteria and directly test mixture performance. The constituent material and mixture composition requirements should be kept to minimum to allow innovation. Instead, information regarding the materials and volumetrics should be collected to aid in optimization of mixture performance. Next, aging should be performed on samples to simulate field conditions. And finally, the mixture should be tested using the chosen performance-based tests and verified against the specified criteria. In order to help designing mixtures based on performance, I have summarized findings from 200 literature sources and created a table that tries to predict possible consequences of changes in mix design. The table lists effects of 17 different parameters on 6 performance indicators. It was created by searching what would be the most likely trend of a performance-based test when changing a particular mix design parameter. Let's look at an example. Say you have too much rutting in your asphalt. What can you do? You could use a harder binder, but that will reduce cracking resistance and workability. You could also use more angular sand, but you have to remember that this will require more compaction effort to avoid overly high air void content. We can also take a look from the other side. Let's say you want to use high content of reclaimed asphalt in the mixture. What changes should you expect in the performance? The rut resistance is going to improve and stiffness will raise, but fatigue might get compromised just like low temperature cracking. Make no mistakes, asphalt is a very complex material, and this table is a simplification of the different effects that we can expect. Moreover, we do not yet have tests that can fully predict the pavement performance. But what are the alternatives of advancing performance-based tests? We could run business as usual. Tailor the existing volumetric requirements by adjusting the empirical relationships each time new materials or technologies are introduced. This, however, slows the innovation process, and in some ways this is similar to chasing a living train. A more promising approach would be to introduce performance-based tests for design and quality control of asphalt mixtures. In this way, contractors would be given the tools that are necessary to encourage development and approval of innovative solutions leading to increased durability, improved cost effectiveness, and reduced environmental impacts. Instead of chasing the train, by using performance-based mixture design, road agencies would actually lay down the track to the direction they wish the innovation to be steered, while allowing the contractors to be the locomotive that drives the advancements. If you're using performance tests, be sure to read the full paper on performance-based design of asphalt mixtures that was published in Materials and Design. I will put a link to this paper below the video. If you like this video, please send it to your friends. I shared it with my friend Superhero Bitumen, and he even stopped sweating. To find out why was he sweating in the first place, you'll have to watch my TED Talk. My name is Martin Zaumanis, and you'll find all my research on zaumanis.com.